In this video, I'm going to show you my Mazebot. Now, I started building Mazebot with a square metal frame with space in between the frame for gears. When I added in the gears, I added a high to low ratio. So I have big gears that are the drivers and then smaller gears that are driven, and that's to give it more speed and less torque. Then I have two motors in the middle. One spins the left wheels and the other spins the right wheels. And the gear, the way that turns, it makes the wheels on the side turn in the same direction. So it's just transmitting the power to both of the wheels. Then I added my wheels. I have a bigger wheel in the front, and that's because I had a hard time getting over the ramp with the smaller wheels. Then I have my battery in the back. It's the blue battery. Then I added the Arduino controller. And in the very front, I have that red and gray bump switch. And that's how the whole maze tracking worked, where when it runs into a wall, it knew then it needed to turn. So when that switch is pressed, it knows that it has hit the wall. For my code in Mazebot, I created my own functions. Both of them are to control the motor speed. The first one sets a specific time to control the motor at that speed. So it sets the motors to both go forward, and then I say to do that for 1 second. So that's all it does for that 1 second. The next one is just motor control, where it just sets the speed, but it immediately does that and goes to the next task. So it doesn't have a set amount of speed, it's just how long until the next time the motors are told to do something else. In void loop, I have a while not done loop. So at the end of my code, when I've reached the end of the maze, I can tell the Mazebot to stop. I start my code by driving the motors forward and reading for the bump switch. I also print on my LCD that the robot's going straight. So how I solved the problem of what to do when it hits a wall, whether to turn left or to turn right, to go how far, what I did is I created if statements. My first one is if the bump switch is pressed and step is equal to 1. In the beginning, I set step equal to 1. So what it does there is it tells the motors to stop. Then it prints wall detected on the LCD and prints turn left. Then I tell the motors to back up and then turn to the left. And then I set step equal to 2. Now the code goes back to the start and tells the robot to drive forward while looking for the bump switch. And it prints straight back onto the LCD and gets rid of wall detected and turn left. Now, when it hits the wall, bump will be equal to 0, and now step is equal to 2. So it enters the next if statement, which tells it to stop. It says wall detected, turn right. Now this is where the ramp is, so I have to do a little bit of extra work. So I drive it backwards, I turn it, I drive faster than I normally would to the ramp. Then I speed up one of the motors because it would always fall off the left side of the ramp. And then I set it back to normal after that adjustment, where they're both going the same speed. And then when I get down the ramp, I reverse the motors to slow down. Then it goes back into the same, looking for the wall. It goes into the straight code, where it sets the motors forward and is looking for the bump switch. Now when it reaches the next wall, it hits, and step is now equal to 3. Now, then it turns right and sets step equal to 4. So now that we're in step 4 and it's looking for the next wall, when the bump switch is pressed and step is equal to 4, it prints wall detected. Now it prints complete. It drives the motors backwards, turns it around 180 degrees, and then stops the motors. And I set done equal to 1, which ends my while loop and completely removing the ability for the the motors to drive anymore.